Okay, so as the last short segment about generative processes in music, uh, I would like kind of walk you through this website. It's actually self-contained. You don't really need me, but I think I can do this kind of pretty quickly and maybe give some comments about what we see here. Oh, sorry about that. Okay, so what is a generative music? So, I mean, this presentation is really going through a lot of new stuff that you might have heard and didn't realize that this is the way composers did this. So it's kind of meant a definition of a system as a set of working parts and principles and procedures. Okay. So it starts, and I kind of like this because it starts with contemporary. Well, 65 is not so contemporary, but still, it's a modern music. Steve Reich, it's called Rain. He designed a generative mechanical system to compose music. So you know, it has these two tape recorders, and they had a recording of speech.
If you use speech, which is, I found a whole lot more interesting than using electronically generated sound, which was the other possibility in those days.
So I'll skip
you get the meaning of the words, and then you get the speech melody. Dum ba ba da, dum ba ba da. It's going to rain.
So go through this, but you know, you take now these little phases. You basically play back one loop slightly slower, one slightly faster. And
electronically generated, 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 electronically generated,
then it will basically sync up again. Well, you can think, well, this is a conceptual experiment. Yeah, and a lot of experimental music started with these conceptual experiments, maybe not like Xenakis, who was totally abstract, but doing things that you can basically have a loop and slightly shift out of phase, in phase. But Steve Reich actually developed this into a lot of interesting techniques. And the idea that he could discover new musical ideas by using such a method. So here I kind of a little more of a musical example in the sense of kind of having this notion of these are two different parts, the piano phases, and this one for some reason it's a YouTube video, but it's stuck. So it's actually good because when they play together, oh no, they play together now, so it's a confusion. So piano phases is really that idea of a tape, but now he actually composed bars of music which were almost similar but had a little shift in them. And you play these two lines together and it creates quite an interesting musical texture where you get new rhythms created. So instead of text, speech. I hope you can hear me talking over and it's not too annoying. You would get this kind of musical composition with always little variations. Let's listen to this. Okay, now the video plays again. So the other piece on the left is pendulum music. It's much more like a physical installation type of thing, where he spins, he lets these microphones, basically like pendulums, spin above speakers, and every time the microphone hits a speaker, if I can, yeah, I hope you can still hear me better. So as I said, this is kind of loops of piano music that are, you know, actually performed by a musician, if you wish. And these are pendulums, and every time they pass above a speaker, they get into this kind of resonance feedback loop that they create the sound. And because these pendulums move in a slightly kind of different speeds, you get also these patterns and rhythms. So yeah, so actually composers use these ideas to do stuff which seem to be like novel and interesting. Much more popular was Brian Eno. He became kind of famous for music for airports. And in this process, he kind of replicated what Steve Reich did. but he used really tapes that had kind of notes with pitches and slight variations. And you would get this kind of ambient music. So you can think about these tapes coming in and out. They slightly are out of sync. They're designed to create interesting chords. Note that every tape here is not just a tone. It has some sort of like little breath or movement or vibrato to it. And you can create these infinite compositions this way. Now this looks to be very kind of simple in some sense, that you could kind of mathematically recreate something like this, right? With looping through sound files. You have to design them also in some kind of a way. Now he actually went on and created more systems like this. This is just another example of Terry Riley, an American composer who also composed music by giving all kinds of options. I'll kind of skip this a little bit, but it was kind of a generative system, social in the sense that you had a bunch of musicians playing loops. So maybe I will kind of go and skip this one and let you check this out on your own. So it kind of gives this idea of a generative method or generative art where you can use kind of mathematical formulas, but these are all kind of designed by musicians, which very much handcrafted. Brian's Eno, you can actually download a bunch of his apps. There is generativemusic.com, I think that's his, or just Google it, Brian Eno, Generative Music. He has a bunch of apps that can make, pretty pleasant music go. It's ambient music, but you can have this infinite computer-generated piece running on your phone, where you can a little bit adjust, or it has some controls that can modify the type of music you're using, actually Galaxy Reflection is an app. So having some other ideas that you can kind of affect, or you need to have some kind of control. A lot of the examples before had really no control. It just kind of used ideas from juxtapositions of things or triggering things in random ways to create interesting music. And if it was not really strictly designed to emulate the style, it will create an infinite stream of music that the composer had kind of to find his logic and aesthetics for it. But you can have a lot of generative things, like you can generate a lot of patterns, and then you can kind of start playing them. So you can have like drum loops, right? And you can always alter them, and you can have small alterations within a pattern. So drum machines are a very natural place where you would kind of add randomness. Okay, let's move on. John Cage is a name that you should know, mostly because he was revolutionary in his thinking. Some people find his music very provocative, but can just check this out a little bit more in detail. With his compositions, he used I Ching and other ways of throwing dice and composing music. Grammars were actually used a lot before the machine learning algorithms kind of took that place. People would write grammatical formulas and rewrite grammars. There is a software called Improviser. It's not part of this presentation, but by Bob Keller, who is from Harvey Mudd College. And he writes, it's actually a software that allows you to also learn improvisation. And he had written a lot of grammars for different jazz improvisation styles. And, some of his recent work actually uses deep neural networks to learn these grammars. So you can learn grammars. That's it's not exclusive. It's not that you say do stochastic or machine learning probabilistic methods. But you can think about writing the logic of rhythms as this rewrite grammar. So we're not talking about this at all in this class, but I wanted kind of to bring this to your kind of attention that these are approaches that are easily programmable. They don't have the machine learning to it unless you are able to learn these grammars from examples. But simple grammars are straightforward, so you can actually write them yourself. And once you get to try to capture with the grammar very complex structures, these grammars might be pretty intimidating. So this is kind of like if you write such a grammar, you can start generating the music with these patterns. So, okay. And you can also have a lot of music that is triggered. I'm kind of skipping a lot of text, so just going to go yourself and try to check this. But you can map data to music. So this is going to reference to some project that uses data from Helsinki tram system to generate music. We'll go forward. Skip that. I don't know if actually right now in Helsinki at 8:35 p.m. if they're actually reading the materials, but some people try to sonify Wikipedia. So sonification is also kind of something that people do. And finally, kind of we get to the generative neural network systems. Oh, that's another example of Innostrope where you do have some kind of a user input. So this idea of meta creation or creation that you specify something on a very high meta level. In this case, it's maybe painting and drawing with your finger that affects the generative system. I think becomes one of the central topics of the conferences on computational creativity and music meta creation. Because once we have all these systems that can generate music, now we expect a little bit more. We want to use them in a way that fits something that we need. And this is, again, maybe a little bit of an abstract application, but the most concrete one would be, a system that improvises with the musician, and the meta specifications are music that comes from another musician, or video game music, where the meta specification comes from the actions or the scene where you are in the game. But you can think a lot about any other interactive agent that generates music for you, but it doesn't do this in the blind. He actually has to have some sort of a reference to an outside input that's contextually driven. Yeah, it kind of explains a lot of the ideas of what the listener can do. And you can also have, nice designs that allow you to compose music really intuitively. And I think this will kind of complete this presentation. I'll play with this. I think you can realize what it is. I mean, you have these notes here to keyboards on X and Y. You have a chord going in this dimension. You have one single line going in that direction. They're arranged in such a way that one becomes a melody, one becomes a harmony, and also they're selected. So not all of the notes are there. You can actually, if you're playing on a key. So, you can really create music by moving the mouse, and it's amazingly simple. So. Okay, I couldn't hold myself. All right, so here's my composition for this class, using moving the mouse and trying to kind of create some kind of an interesting musical segment. Yeah, trying to go with chords low and high and going all the way up. And think about designing really music that might sound, depending of course on your stylistic preferences, it sounds a little bit more designed, and you don't really need to know too much about musical theory if you know try to listen and have some sort of a inspiration, or at least an attempt to kind of get yourself going with some musical ideas in kind of high level. Um, well, that's what these software and the representations allow you to do. Okay, sorry. Yeah. So, neural networks. Yeah, I mean, please follow this presentation. And this presentation kind of just gives some motivation. It doesn't give you much examples about. We'll talk about Markov chains and how you can train them. And mentions the Magenta project. And there are a lot of apps that you can download on Magenta and basically either use on standalone or plug them into software like Ableton. So the fact is that this is where we're going today, and I think this is kind of a good motivation for the class. This presentation doesn't talk at all about synthesis, and we are going to talk about signal processing, of course, as we did. So yeah, just check it out, and I'll stop the recording and maybe talk a little bit about what you think about all this.